And Descartes' rule of signs said as follows. Given a polynomial p of x the number of positive real roots is the same as the number of sign changes of p of x or less by an even number. Or less by an even number. Yeah, you know, the idea of it is not, once I share the idea with you, you'd probably be able to explain it to somebody pretty easily. And here's the idea. You don't have to write this down, but if you look, let's say we have p of x is equal to x to the third minus 2x squared plus x minus 1, okay? Look, x to the third, is it positive or negative? It switches signs to be negative, then switches signs to be positive, then switches signs to be negative. So how many sign changes are there? 1, 2, 3. There's 3 times that the sign changes. So therefore, the number of positive real roots is either 3 or you reduce it by an even number. So 3 or 1 or none after that, okay? So that's what we have. Now, that's positive. What about negative? All we do is we just switch it to negative x, and it'll tell us the same thing. So the number of negative real roots is the same as the number of sign changes of p of negative x, or less by an even number. So it gives us a general idea. It gives us a general idea. And I'll show you what I'm talking about here in a second. We're going to do the first 4 problems of your assignment together here. And I don't use this very often. I don't use this very often. But you should see it so that if you take a higher math class, you'll know how to do it. And second of all, you may end up using it at some point. Okay, page 288 in your book, I have problems 51, 52, and 53, and 54 written down. Page 288, you can write these down as you see them. Just leave a couple lines in between, and that'll be enough. And there's more to this unit. We can actually find an upper and lower bound of the value of the roots. But again, I just don't think that that's going to be entirely important to us as we move forward. I think that we're going to be able to do other things. So we're looking at the number of sign changes here, okay? We're looking at the number of sign changes. And in the first example, we have x to the third minus x squared minus x minus 3. Okay? So, how many sign changes are there? 1. It starts from a positive, it goes to a negative, and then it stays negative thereafter. See? Starts positive, goes negative. So this would represent the single sign change right there. So that means that there is one positive real root. Now, in order to find out the number of negative ones, I would do p of negative x. Now, follow me through here. Okay, I'm going to plug in negative x. If you take negative x to the third power, are you going to come up with a positive or a negative? Negative x to the third. Minus, what do I get if I take negative x and square it? Positive x squared. So minus a positive x squared minus, if I plug in negative x for x, I get negative x. So minus a negative x or plus x minus 3. Now, how many sign changes do you have here? 2. 2 sign changes, so 2 negative real roots. Or it could reduce by an even number, so you could have 2 or 0. It's that would be the most. That would be the most number of negative and positive roots that we have. So that gives us a little bit of an idea. Notice what do the 1 and the 2 add up to? 3, which is the number of roots of the polynomial. Yes? Because it's subtraction, and when you plug in a negative x and square it, you get a positive. So it's minus a positive x squared. No? Yes. Okay. Well, we'll try the next one, see if it works out. How about this one? How many sign changes are there in 52? 1, 2, 3. 3 times the sign changes. So 3 positive real roots. How many negative ones do you think there's going to be? There's already 3 possibly, so my guess is that there will be none for the second one. Let's see what we get. If we plug in p of negative x, we get, what's negative x to the third? Negative x, so you would have a negative 2x to the third, that would become. If you notice, the sign switches for the odd powers. It doesn't switch for the even powers. What do you get if you square negative x? Positive x squared, so it's minus a positive x squared. Plug in a negative x for there, you would get a minus 4x, and you would get a minus 7. How many sign changes are there? There are none. So there is 0 negative real roots. Now, there could be either 3 positive real roots, or there could be 1 positive real root and 2 irrational roots. Laura, it's so good to have you back today. Rumor has it that you've been a little under the weather. Are you feeling better? Did you miss mathematics? Math missed you. All right, well, very good. Good to have you back. We have 3 positive and 0 negative. There we are. Let's try one that's slightly different. Okay, 2x to 6, 5x to 4th, minus x to the third, minus 5x minus 1. How many sign changes are there here? 1. You go from a positive to a negative. That is the only sign change that we have. So 1 possible positive real root. If we do p of negative x, we get, what's negative x to the 6th? It's going to be positive x to the 6th, right? So you have 2x to the 6th. How about if you take negative x to the 4th? Positive x to the 4th. Negative x to the third will give you a, when you subtract, you'll get a positive x to the third. positive 5x, and a minus 1. How many sign changes are there? 1. 1 negative real root. Well, how many total roots am I going to have to this problem? 6. So if I only have 1 positive and 1 negative, where's the other 4? Positive real, so that means that there are 4 imaginary. 4 imaginary. This does account for rational and irrational. If I made that mistake earlier, my apologies, but we could have 4, in this situation, we do actually have 4 imaginary solutions. 4 imaginary. So this is just talking about real roots, positive or negative. The unreal ones, like imaginary, we don't know about. What? Yeah, and I'm not going to test you guys on this. This is the only time we'll investigate this, I think. So I might bring it up later, but it's not going to be a major point of retest on. This is just a kind of might be something you choose to use. How many sign changes here? 0. 0 positive real roots. So let's apply our thinking here, people. Do you understand that you can't plug in a positive number and get 0 for this? If you plug in a positive number, you're going to come out with a positive number. You're not going to come out with 0. If you have any chance of coming out with 0 here, you're going to have to plug in a negative number, right? So if you're trying the rational roots theorem, would you have any sense at plugging in a positive number? No. We would only want to plug in negative ones. Let's try the negative one, p of negative x. Negative x to the fourth would be x to the fourth. Negative x to the third would be a negative x to the third. Negative x squared would be a positive x squared. Minus x plus 12. How many sign changes are there? There is 1, 2, 3, 4. 4 sign changes, so 4 negative real roots, possibly. Okay. It could be 2 negative real roots and then 2 imaginary ones. Or it could be none. Could be none and 4 imaginary. That's entirely possible as well. So that's the idea. Does that make sense? Not too tough. Here's your assignment. It's pretty lengthy. The first set of problems have all rational solutions. There are no irrational numbers involved. I want you to practice exactly what we did yesterday. You're going to be given a significant amount of time today to work on it, okay? Significant amount of time today to work on it. I suppose I can stop recording.